Let's investigate the intersection of two parameterized curves. Curve number 1 is x equals t minus 1, y equals t squared, and the t values click off between negative pi and pi, and that gives us this curve, and the curve traces out this way as t goes through its values from negative pi to pi. Then our second curve is x is 2 cosine t, y is sine t, so you're going to get an ellipse, and it's on the same parameter from negative pi to pi, and that will trace out this way around here. And so maybe there's a collision here, and maybe there isn't. We're going to find out. The graphs intersect here, but it's pretty clear they do not collide there, as far as the trace does not collide with the other trace, because by the time this parameter has moved this curve through here, this one hasn't got there yet. But let's see an animation on that, because what we're trying to show here is we're going to find these intersection points, but we're also going to establish that the curves, yeah, they intersect, as you can obviously see, but not necessarily at the same parameter value. In other words, they might collide or they might not when they're being traced out. So here we have our curves, and we have our t value starting at negative pi, negative 3.14, and we're going to just run through the values and watch the two traces and see if they collide. So here you go. Here's the other trace starting, coming down. They don't collide there at the left-hand intersection. They might collide. Oh, they miss each other. So they did not collide. That's so fun. Let's just see it again. Okay, so as t runs through these values from negative pi to pi, you can see they do not collide at the left-hand intersection. There's a chance they could collide at the right. Not quite. They miss. Alright, so now that we know what happened, let's actually find first the intersection points of the actual curves. So to do that, we go to curve number 1 and we solve for x in terms of the t equals, rather solve for t in terms of the x, and then plug it into the y equation right here. Take this x plus 1 and stick it in there, and then you get y equals x plus 1 squared, which is what that parabola looks like. Then curve number 2, do the same thing, except we can't really solve it the same way we did the parabola, but it's one of those ellipses, so we know that cosine squared plus sine squared is equal to 1. The y is sine t, and this x over 2 is cosine t. So cosine squared plus sine squared is 1. So x over 2 squared plus y squared over 2 plus y squared equals 1. So here's your equation in terms of x and y. So we just want to find out where those curves intersect. So what I did was I took this expression for y and substituted into here, into that y in the other equation, and I get this. Did some algebra, cleaned it up, factored out an x, solved it over, factored out an x. So x is 0, is a point, a coordinate for intersection, and the y coordinate there is 1, so you have 0, 1. And looking at the curve again, you see that 0, 1 was the intersection. Then we try to find the other x where they might intersect. This comes from here. We want to know where that's 0. And so I put this into TI and did second calc 0 technique, and I found this point, which is right here. Okay, and I just abbreviated that, rounded that off to -1.72, plugged it back into the y of one of the equations, a simpler one, and got 0.52. So here's your intersection point. So we have 0, 1 and -1.72, 0.52, which when you look on the curve here, these intersection points, that's exactly where it looks like they should be. Okay, so as mentioned earlier, the curves definitely intersect, and we saw where they intersected, but we saw in the animation that the traces do not collide, meaning the trace for one curve arrives at the intersection point at a different parameter value than that of the other curve. So the traces miss each other, as we saw in the animation, and as the parameter progresses through its values. So now we visually saw they don't collide. Let's check it. Let's just check the simpler point, 0, 1. Alright, so curve 1, for the x to be 0, t would have to be 1. And the y value, in order to be 1, has to be plus or minus 1, but it's got to be a single value when it crosses there. So it'd have to be 1, because that satisfies both. Okay, and then similarly, doing curve 2, setting up the x equal to 0 and the y equal to 1, we find that you have t equals pi over 2 or negative pi over 2, but over on this one, only pi over 2, and solves that. So it's pi over 2, and that does not match up with 1. These two here and here are not equal, and that proves mathematically that the traces do not collide as the t values go through their range of values, because t is 1 when the first curves arise at 0, 1, and t is pi over 2, which is not 1, when the second curve arrives there. That's why they missed. And just for fun, let's just see that one more time. Here we started at negative pi. The t values click off on its way to pi. You can see the trace of the ellipse happening now. The parabola misses that first point. Almost get there, but missed the second.